The need for truly portable oscilloscopes has continued to show significant growth over the past few years, especially in the area of computer field servicing. Recent surveys show that in 1969, approximately $35 million was spent for field service type oscilloscopes. The same surveys estimate that the market will double in the next few years. This means that by the mid-70s, 1 out of every $5 spent on oscilloscopes will be for portable field service instruments. And here to familiarize you with our first entry into this market is Chuck Donaldson, Product Manager at the Colorado Springs Division.
I think that perhaps the best way to introduce you to our new 1700 series of oscilloscopes is to first categorize the major differences between the three primary markets where oscilloscopes are sold. The laboratory market, which is the largest, has requirements for versatility, fidelity, and accuracy. The purchaser of a laboratory oscilloscope can't typically predict what type of measurement he is going to be making 6 months from now, and therefore finds it difficult to specify the exact type of vertical amplifier he may need. The user generally wants to know as much detailed information about his waveform as possible and is willing to pay a little more money to get the required versatility and accuracy. The 180 and 183 systems with their plug-in capability are well suited for this market area. Second is the production market. Measurements in this area are generally a little easier to define, and the measurement requirements usually remain constant for a longer period of time. In many cases, however, plug-ins are important to enhance measurement capability and minimize capital equipment costs. Purchases are primarily made in larger quantities, and the market is more price sensitive than the laboratory area. Large CRT screen size and convenient rack mounting tend to be important factors in making the buying decision. Again, the 180 and 183 systems are aimed towards this market. And in low-frequency production markets, the 1200 series can also be promoted. Third is the field service scope market. Here, the measurement requirements are well defined for much longer periods of time. In most cases, the oscilloscope will be used to test and service a specified piece of equipment until it is obsoleted or replaced. The oscilloscope is then usually replaced when the new equipment is installed. The oscilloscope requirements for field service applications are somewhat different from those for lab and production environments. The scope needs to be lightweight and rugged. Rack mounting is usually not a requirement. Since the measurements are well defined, plug-in versatility is generally not needed. This allows a cost reduction, which is quite important since purchases are typically made in fairly large quantities and are very price sensitive. The 1700 series has been specifically tailored to meet the requirements of this growing market area. Presently, the market can be broken down into 4 application areas. The majority of oscilloscopes are used for servicing digital equipment and peripherals that incorporate T-squared-L integrated circuits and slower forms of logic. The first members of this oscilloscope family are the 1700A and the 1701A. These two scopes, with their 10 nanosecond rise times and 10 nanosecond per division sweep speeds, are tailored to satisfy the measurement applications up to and including T-squared-L. In addition, they both incorporate dual-channel vertical amplifiers with 10 millivolts per division deflection factors. The 1700A is a single time-based oscilloscope, meeting the majority of needs in the analog area and some digital applications, while the 1701A includes a delayed sweep, which is mandatory in the majority of digital applications. These oscilloscopes are very compact, weighing only 24 pounds without batteries and accessories, and therefore are easily carried to any test location. The display area is a full 6 by 10 centimeters. A 19.7 kV accelerating potential gives a bright display, which is essential for viewing very low rep rate fast rise time waveforms. In addition, the CRT is very sensitive with deflection factors of 1.5 volts per division in the vertical axis and 3.5 volts per division in the horizontal axis. This high sensitivity helps to reduce the scope's total power requirements to less than 18 watts, facilitating battery operation and minimizing overall weight. The new corporate knobs and colors are being used on the 1700 series to enhance the appearance of the front panel and to make the lettering easier to read. In addition, the front panel controls have been laid out so that the user may quickly learn the operation of the oscilloscope. Push-button switches have been used wherever possible to further simplify the oscilloscope's operation. When all push buttons are out, the oscilloscope is in its most normal mode of operation, and a trace may be quickly obtained on the CRT. In the full out position, a dark ring appears around the push button. This corresponds to the panel marking that has a ring around the letters. The full in position of the push button corresponds to the marking that has no ring. Uncal lights have been included for both the vertical and horizontal verniers, indicating when the oscilloscope is in an uncalibrated mode. The operation of delayed sweep has been simplified to better tailor the 1701A to field service needs. For example, the delayed sweep controls have been separated and placed in the gray strip you see here. The insignias on the front panel representing the time per division controls indicate either main or delayed operation. The functions of mixed sweep and calibrated delay interval have been eliminated from the standard models since they are rarely used in field service applications. They are, however, available as factory options. Internal triggering for both the main and delayed sweeps is specified at less than half a centimeter of signal to 35 megahertz and typically less than 1 centimeter to 75 megahertz. As the frequency is varied, some double triggering modes may be encountered, but are easily eliminated by adjusting the trigger stability control. As little as 50 millivolts of signal may be used to externally trigger the main sweep up to 35 megahertz, increasing to 100 millivolts at 75 megahertz. Useful triggering, however, may be extended to 100 megahertz. This requires that the trigger circuits be very sensitive. Therefore, below about 50 kilohertz, always use AC slow trigger coupling to prevent any high-frequency noise from triggering the display. The controls and connectors on the rear of the 1700 series are somewhat different than on other HP scopes. The power mode switch allows the oscilloscope to be powered from either an AC line, an external DC supply, or an internal battery pack. In the AC line position, power is supplied through a new power cord and connector that conform to the IEC safety standards. If it is desired to convert operation to 230 volt lines, the power cord must be removed and the window moved to the left. The 115 volt fuse is ejected by pulling on the tab. The switch is then moved to the 230 volt position as indicated on the power switch input plug. The proper fuse for 230 volt operation should then be inserted and the power cord reconnected. In either 115 or 230 volt operation, the line frequency can vary from 48 to 440 hertz, and the input voltage can fluctuate plus or minus 20% without affecting scope operation. When the power mode switch is set to DC operation, DC input voltages from 11.5 to 36 volts may be applied directly to the DC input connector. This range is large enough to accommodate either a slightly discharged 12-volt car battery or a 28-volt supply commonly used in aircraft. The DC power input is isolated from chassis ground and may be floated plus or minus 200 volts. This is particularly important when opposite ground polarities are encountered. A mating connector to the DC input plug accompanies each instrument so that the customer may adapt to a variety of available connectors. In the internal battery mode, power is obtained from an optional 26¼ volt nickel-cadmium battery, which is completely contained inside the oscilloscope. The scope requires a maximum of 18 watts of power, allowing up to 6 hours of operation from the internal battery pack. When the battery becomes discharged, the front panel power light will blink, indicating that the battery should be recharged. To recharge the batteries, turn the power switch off and put the power mode switch to AC operation. Plug the oscilloscope in and the batteries will completely recharge in 14 hours. Whenever the oscilloscope is operated in the AC mode, a trickle charge is maintained on the batteries. Instructions for recharging the batteries are printed on the back of the oscilloscope. The ability to operate the oscilloscope from DC power sources requires a DC to DC converter. In the 1700 series, the converter is operational in all 3 power modes of operation. In the AC mode, the line voltage is rectified and filtered before being applied to the input of the converter. While in the external DC and internal battery modes, the sources are connected directly. A fuse at the input to the converter protects the oscilloscope and power sources from damage caused by an instrument malfunction or an improper source connection. In addition, the fuse will also open to protect the internal battery pack if the oscilloscope is operated after the low power indicator light begins flashing. A DC coupled Z-axis input is on the rear panel, but the gate and sweep outputs commonly found on lab scopes have been eliminated, since again, they are seldom required for field servicing. The outer covers are secured with quarter-turn captive fasteners, allowing them to remain with the covers when they are removed. The battery is located in the lower rear section of the oscilloscope. It is easily removed by loosening 2 screws and disconnecting the internal power plug. Because of the unique nature of field servicing, a customer engineer requires that his oscilloscope be readily available to him night or day. This means that high failure rates and long calibration cycles cannot be tolerated. Therefore, the 1700 series has been designed for high reliability and ease of service. The low power consumption of less than 18 watts not only facilitates battery operation, but also means higher reliability, since most of the active components are operating at only 10 to 20% of their power ratings. For example, note that the vertical output transistors are standing in free air and not mounted in a massive heat sink. Also, since no fan is used to cool the instrument, ventilating holes are not required, and less dust and moisture are allowed to accumulate inside. The reliability of the 1700 scopes has been further increased by minimizing point-to-point wiring and solder joints through the use of plug-in assemblies, motherboard, push-button controls, and printed circuit rotary switches. In addition, the tunnel diodes in the trigger circuit have been replaced with off-the-shelf emitter-coupled logic ICs, giving more reliable operation over a wide temperature range. You may have noted a minimum number of adjustments throughout the oscilloscope. Only 39 internal adjustments for the 1700A and 44 adjustments for the 1701A are required. 18 of these are contained in the high-frequency attenuators. This compares to the 70 or 80 adjustments in most 50 megahertz scopes. This means that if all of the controls in an operational instrument were misadjusted, a technician with a working knowledge of the scope could completely recalibrate it in less than an hour. Serviceability is further enhanced with the use of plug-in printed circuit boards in the time base and power supply assemblies, allowing easy removal and replacement. In addition, the test points, internal adjustments, and square pin connectors are easily identified. All of the major assemblies are modular in construction. That is, they are quickly removed for servicing and replacement. This also means that subassemblies such as vertical attenuators and front panel switches are easily replaced. If fast turnaround time is essential, the problem need only be isolated to a major assembly. This unit can then be replaced with a known good one, and the instrument can then be calibrated and returned to use in the shortest possible time. As you can see, the 1700A and 1701A have been tailored for field service applications. They are truly the customer engineer scope, both inside and out, from being rugged, portable, and easy to operate, to being reliable, easy to service, and quick to calibrate.
Chuck, will there be a full line of accessories available for these scopes?
Yes, we'll have a full complement of accessories for the 1700 series. A front panel cover is shipped with each instrument along with two 10006A probes. The cover helps to protect the display and front panel controls from dust, rain, and mechanical damage. An operating instructions decal is conveniently placed inside the cover so that it will remain with the instrument and be available when needed. The instructions give a brief turn-on procedure and a description of the external controls and connectors. In addition, the cover provides adequate storage for probes, power cord, and miscellaneous accessories. A polyester contrast screen is also included with each scope. It offers extremely good contrast between trace and background, especially in high ambient lighting conditions, and also reduces reflections from the CRT faceplate. An optional metallic screen is also available which reduces RFI radiating from the CRT. Other optional accessories include the rechargeable battery pack, which is required when line power is not available or when the oscilloscope must be isolated from the equipment being checked. Since DC power supply operation is standard on all 1700 series scopes, the internal battery may be added at any time without modification to the instrument. Also available is an optional viewing hood. This hood is very useful for viewing fast rise time, low repetition rate phenomena, and is small enough to fit inside the storage cover. The scope card adapter allows a 1700 series scope to be mounted on the HP 1118A and 1119C or D test mobiles. And finally, a camera adapter is available for mounting the Tech C30A and C31 cameras, since none of the Hewlett-Packard cameras can adapt to the 1700 series. A new HP camera, however, will be available in about a year and will mount directly on the 1700 series scopes.
I noticed that some of the standard features have been eliminated. How come?
Several of the features found on laboratory-type oscilloscopes have been deleted from the 1700 series because they are not required for field service applications. These include the external trigger input for delayed sweep, the delayed trigger output, and the gate and sweep outputs. Other features that have been eliminated from the standard models but that are available as options are the following: mixed sweep on the 1701A only, calibrated delay, again on the 1701A only, external horizontal input, and finally, channel A output for cascaded operation. The important point to remember is that by tailoring the 1700 series scopes to the specific needs of the field service market, we are able to obtain a significant price reduction. This is a particular advantage since most purchases are in large quantities of 100 units or more.
How about 50 megahertz? Don't I need that additional bandwidth?
No, not really. The 1700A and 1701A are specifically designed to meet the needs of the digital field service market, including the T2L devices. This represents the vast majority of the market today. Unlike the laboratory market, accurate rise time measurements are rarely made in field servicing. But when they are required, even a 100 megahertz scope is too slow to give accurate quantitative results. On the other hand, pulse timing measurements are extremely important in servicing computers and peripheral equipment. And here the 10 nanosecond per division sweep speed is the significant specification. Increasing the bandwidth to 50 megahertz will not improve the timing accuracy. Let me show you an example on the Tech 453. Here we are displaying the propagation delay of a T2L gate by comparing the positive input to the negative output. On the 50 megahertz system, we determine the delay to be 7 nanoseconds. Now, let's compare this display to that on the 35 megahertz 1701A. We find that not only is the propagation delay identical, but that the larger display improves the visual resolution and makes the measurement easier to interpret. Again, since an increase to 50 megahertz is not required, the price of the scope can be reduced.
Why do we only go to 10 millivolts per division? Tech goes down to 5.
Here again, looking at the application, T2L amplitude measurements with their typical 3.5 volt swings are no problem. Even emitter-coupled logic waveforms having a typical amplitude of only 800 millivolts can be viewed even when using a 10-to-1 divider probe. If, however, some special applications require a lower deflection factor, the option 009 offers 1 millivolt per division cascaded operation at reduced bandwidth.
How does the 1700A differ from the 1701A?
The 1700A is nearly identical to the 1701A, except that there is no delayed sweep. Also, a divide by 10 push button has been added to the external trigger input of the 1700A, extending the normal plus or minus 1.5 volt dynamic range to plus or minus 15 volts.
Will there be videotapes available for customer training?
Experience in this market area has shown that customer training is extremely important. As a matter of fact, many customers are requiring that training be available as part of their buying decision. We are planning to produce a general series of videotapes in the areas of operation, applications, and servicing of the 1700s in the next few months. In summary then, the 1700A and 1701A are the first members of a new family of portable field service oscilloscopes, complemented with a full line of accessories and sales tools. These first two entries are specifically tailored to meet the vast majority of field service needs today, including T2L applications. Additional models will continue to enhance the 1700 series capabilities, meeting the future needs of this large, fast-growing market area.